Hi, this is Zach Semke with Passive House Accelerator, and thanks for tuning in to this special bonus episode of the Passive House podcast, recorded at Passive House Network's 2023 conference in Denver, Colorado. And a big thank you to EnerSign for the support of the series. The interview you're about to hear was hosted by Ilka Cassidy, co-host of the Passive House podcast.
So hi, this is Ilka Cassidy with the Passive House Accelerator podcast, and we are in Denver for the Passive House Network conference right now. And I just attended a very excellent workshop. Yeah, maybe we can talk about it a little bit more. But first, can you introduce yourself and tell us what you do?
Yeah, of course. Thank you. I'm Enrico Bonilauri, the co-founder of Emu Passive. We are a company based out of Denver. We mostly focus on training and consulting. We used to be an architectural practice, but we saw that in order to bring Passive House to mainstream, we needed a lot more training. So that is a switch we took around 2016 when we moved the company from Italy to the US.
That's great. And so what was your workshop about?
Today's workshop showed the results of a long research that we undertook in comparing different building standards that are common in the US. Building standards including IECC, the Energy Code, including Energy Star, including the DOE Zero Energy Ready Home, Pretty Good House, California Title 24, as well as passive standards such as Fuse and PHIs. So the comparison was looking at the requirements as well as how these standards improve on metrics that are important in buildings, not just in terms of energy efficiency, but also in terms of thermal comfort, indoor air quality, resilience, and durability.
Yeah, it was really, really amazing to see all these numbers in comparison and very eye-opening. So for you, what was the main takeaway from this pretty large-scale exercise?
So thank you for your kind words and thank you for making it. It was a 4-hour workshop. The study took us about 2.5 years to complete. And over these 2.5 years, we also had the chance to evolve what we were looking for. Originally, we were trying to find a way to compare PHI and Fuse metrics, not just in terms of energy efficiency, but also how does the volume-related ACH 50 compares to the surface-related air leakage maximum allowed by Fuse, allow for a comparison that would be statistically significant. So we looked at 50 different single-family home projects as a base for that. But I personally learned a lot in researching standards other than PHI. I've been working with PHI's standards for 12, 13 years, so I'm very familiar with that. But I didn't know much about Energy Star or the EPA Indoor Air Plus standard. So I've learned a lot, so I appreciated that. And it's something that is going to feed our training in the future. But also what came out to be discouraging is to see the evolution of building code or how building code is slowing the way it changes. Or we modeled the what we expect to be the 2024 Energy Code, which is not published yet, so we had a draft. But we modeled the 50 projects based on the draft, kind of as a way to have a look into the future of how the market is going to evolve. And I think that makes all voluntary standards look good because they provide better value, better living conditions than just code minimum build buildings.
Yeah. And you said you modeled them. So you used basically one modeling tool to compare all these different standards with each other. Which tool did you use, and how do you basically align all these different standards to make them comparable?
This is why there's going to be a white paper published for this, because even just to define what a standard is an exercise in itself. We looked at the minimum compliance for each of these standards. We created each of these in PHPP to have an analytical way to see the impact of R value specifications versus ACH 50 requirements versus Energy Star requires a 15 SEER heat pump versus California requires a certain amount of PVs installed. So it was a landscape that it took effort to level the field and have an equal starting point. And then the tool that we used is PHPP. We had the models, because these were 50 projects that come from the consulting side of our business. And PHPP being an Excel file, it makes it easy to process data past what the tool is designed for. Both PHPP and Woofy Passive are based on the same ISO standard, ISO 13790. So I don't expect, if we had we used Woofy Passive, I don't expect the results to change that much. And at the end of the day, we were trying to compare building standards, not different modeling softwares. So that's why we kept it to the one tool.
Mm-hmm. And you just said you use it slightly differently than what it was designed for. And this is actually something that I would like to investigate overall during this conference, because I'm very curious about modeling and monitoring tools, because I think those are just so important. Besides just basically satisfying certain certification standards, they can be used in so many different ways, even as a communication tool, correct?
100%.
So how do you use your modeling tools beyond just, getting projects through certification?
This is a very important point. There are goals. These are all different goals. Some goals include compliance with one or the other standard. I use my prescriptive R values and U factors for Windows, and therefore I comply with code minimum. That is one way to comply. And you have no idea on how the building is going to perform. That is one big critique against prescriptive approaches, because if you're trying to have a significant impact on the building and the deliverability of the building, the comfort and actual performance, if you're using a prescriptive approach, you don't actually know what you're doing. Like if we are being honest, because prescriptive approaches have a very limited ability to predict, or zero ability to predict, the actual performance. Now, standards such as PHI and Fuse performance-based, they have targets in terms of the maximum allowed heating demand and cooling demand that they allow you to use for the building. I'm not talking about how to set them, but they both have targets that you have to be equal to or less than in order to be certified. Now, those targets of energy consumption for heating and cooling are based on assumptions for internal conditions, and those are for both PHI and Fuse set at 20 degrees Celsius or 68 degrees Fahrenheit for a set point temperature for heating, and 25 degrees Celsius and 77 degrees Fahrenheit for cooling. And that is used around the world to determine how much heating demand and cooling demand your building has, as modeled in PHPP. But that is different, or may be different, from how the building is actually operated. I'm from Southern Europe, I'm from Italy, and thinking of 25 degrees Celsius for set point for cooling, 77 degrees Fahrenheit, that is cold. In Southern Europe, we are used to having 26 or 27 degrees Celsius temperature for cooling. We are fine with that out of cultural preferences and whatnot. But the standard having to be the same across the world, they decided to have 25 degrees. And that is just part of the standard. It's called standard because it's standard. In the US, that 77 degree or 25 degrees Celsius that they defined as cold in Italy, it's actually so hot. It's the same temperature, but the expectation from occupants is different. So when we set up the model for this study, we set up the PHPP models with the 68 degree temperature for heating and 77 for cooling, but in actually looking at the site energy consumption, we actually adjusted the model to have 70 degrees heating and 74 for cooling, because in my opinion, that is more representative of the expectation of building occupants in the US. Does that answer your question?
Yeah, and then so you use then the modeling tool not only for certification, but to also predict a little bit better what the actual outcome is, correct? Yes. And then to take that a little bit further, do you use the results to communicate with your clients? Like, does that sometimes help when clients, I don't know, do clients always come to you already knowing that they want to go through certification, or is the modeling sometimes a tool for you to explain how much better their building becomes if they actually go through certification, and is the modeling results maybe a deciding factor?
So that's a great question. And to give you an idea, we model about up to 50 projects a year. Like, we're a small team, but we have up to 1 or 2 new projects a week. So we have a lot of projects, and that gives us the confidence of being very neutral to the decision that the client makes, because it is their project and their money. We provide the science for them to make decisions. In other words, 80% of projects that come through our doors, they do not pursue Passive House certification. They want to use the Passive House science for their projects to become better. And better is a word that consists of different metrics, thermal comfort being one of them, indoor air quality, durability, resilience, and energy efficiency. So it's not just about the energy. In fact, in the decision making of our clients, the energy efficiency ranks pretty low, whereas thermal comfort ranks pretty high, as well as indoor air quality. In this conversation and in building up this narrative, we've been doing this for many years, and at the beginning, we did not know how to communicate this as well as we do now. I personally had a light bulb moment 6 or 7 years ago, talking to a client. They had a project in Gunnison, Colorado, climate zone 7, super cold, and they were a CPA. They wanted to compare the return on investment on using triple pane windows compared to the double pane code minimum windows. And I was trying to explain here and there and the kilowatts and the payback and all of that. But at one point, I was like, wait a sec. You're going to be miserable with a code minimum window, right? Like, what are you talking about? Well, it's Gunnison, Colorado. Your design temperature is negative 15 or whatever. And if you have a double pane window, you're going to be cold. Like, what are you talking about? It's a new window. Yeah, but windows are not designed, code minimum windows are not designed to be, they're not designed to provide comfort. And what are you talking about? Yeah, the code requirements for windows have nothing to do with comfort. And so then I explained that the requirements for Passive House actually have requirements for comfort, and that is how you drive the decision of windows. And she immediately went for Passive House windows. Mm-hmm. So data is extremely important in providing a handrail for clients to understand this it needs to be about something that they can relate to. I was talking about U values for the windows. They had no idea about a U value. Temperature, they got right away. So it's about understanding the expectation, setting goals, and then understanding the priorities. But the modeling is a key part of this. It provides the science-based handrail for them to make decisions.
Yeah, no, that's all great points. And do you do any monitoring on your projects? Because I feel like that's very helpful data too.
We have, as part of EMU's pilot program, we have monitoring of moisture conditions inside wall assemblies. That is the monitoring program that we have right now. We don't do much energy monitoring because that is a lower pain point for projects as opposed to moisture management. We have a project of a monitoring program for indoor air quality in Europe, and then to replicate the same in the US, monitoring CO2 and particulate matter in passive house buildings and as many code minimum buildings, but that hasn't started yet.
Okay. Great. Thank you so much. And thank you for the really, really eye-opening workshop.
You're welcome, and thank you for the time and participating in the workshop.